Hey everyone, welcome back. In this video, we are going to learn how to factor quadratics where the leading coefficient is not equal to 1. Okay, so to start off today, I want to take a look at a specific example. And let me pull up my notes really quick. Okay, cool. So we're looking at 2x squared plus 16x plus 24. So in this case, we are trying to factor this quadratic. So I started to set up our area model. And to start off, I'm just going to go ahead and split up the 16x for us just to show a cool pattern that we see with our area model. Okay, so here I'm going to write out a 4x and a 12x. And one thing you might notice about our area model is if we look at the diagonals, so 4x and 12x, and we compare their products, so if we multiply the diagonals, here we get 12 times 4 is 48. X times x is x squared. We look at the other two diagonals, 2x squared and 24. Here we also get 48x squared. So our diagonals are equal to each other. In other words, the product of the diagonals is equal to each other. When we multiply the diagonals, we're always going to end up with the same exact product. So another way to think about approaching this problem, if we didn't have the 12x and the 4 and we wanted to try and split it up, let's draw another area model really quick with those not filled out yet. We know that these two blank spots are going to, if we multiply them, we'll get the same exact value as if we were to multiply the other diagonals. In other words, 2x squared times 24 is equal to blank times blank. Now we know there's going to be an x in each of these spots, so we'll end up with an x squared. So let's not worry about the variables for now, and let's just take a look at the numbers or the coefficients. 2 times 24 is equal to blank times blank. So when we're figuring out our puzzle, in this case, what we need to do is find two numbers that multiply to 48. Blank times blank equals 2 times 24, which is 48. And also add to, our other pattern is going to remain the same. They both have to add to 16. Add to 16. So in this case, we could look at factors of 48. We could try out a few of them. As we can see, 4 and 12 are two factors of 48, and 4 and 12 both add up to 16. So 4x and 12x. Finally, when we're finishing up factoring here, one thing we have to watch out for is here's where the area model becomes a little bit more important than cases where we just start with an x squared. What we need to do is factor either the rows or the columns. It doesn't matter which one. Let's do our columns. So looking up, we're going to factor the pairs of numbers and find their greatest common factors and write them right at the top. So on the left side, for example, here we have 2x squared and 12x. These both share a factor of 2, and they both share a factor of x. So 2 goes into both of them, x goes into both of them. Looking to our right here, we have 4x and 24. We can see that 4 is a factor of both of those, and that's it. That's the only factor. Now, when finding our other factor, what we need to do is thinking about finishing this puzzle. So one way to think about this is we have 2x on this side. So what do we multiply 2x by? 2x times what gives us 2x squared. In this case, that's just going to be x. Down here, we have 2x times what gives us 12x. Gives us 12x. That's going to be 6. So x plus 6. You could also use the other boxes too. 4 times what gives us 24? 4 times 6 gives us 24. So finding greatest common factors, looking at the columns or the rows. And then to find the other side, we need to think about what do we multiply by to end up with these areas for these boxes. What this tells us, this area model tells us, is that our final answer in this case is going to be 2x squared plus 16x plus 24 is equal to 2x plus 4 times x plus 6. So just the two sides that we found on that area model. Okay, so this is the process that we go through whenever we have a situation where we have, let me rewrite this, x squared plus some other number times x plus some other number. So a, b, and c are just what we call parameters. In other words, they're numbers that will change what our quadratic looks like and what the factors might be. In this case, we're looking at situations where the leading coefficient, which is represented as a, is not equal to 1. If it's equal to 1, we're just going to be working with x squared plus something x plus something, which we've worked with a lot over the past week. However, in the examples we're learning this week, we're going to have situations where we start with, for example, 2x squared, a number times x squared plus something x plus something. So here we need to go through these steps, making sure that when we look at the multiplies too, we're looking at the product of the diagonals. Let's do one other quick example. Okay, so here we have 3x squared plus 10x plus 8. So again, we're going to start off by drawing out our area model, putting in the two diagonals that we know. We know we have a 3x squared here and an 8 down here. And then we're trying to find our two missing numbers, which are going to go here and here. And again, we'll have an x in each of these spots. Okay, so these two missing numbers, let's use orange. We know that if we were to add these numbers together, we would end up with the middle coefficient, which is 10. So these have to add up to 10. We also know that if we were to multiply these together, we would end up with the product of the boxes that we already filled out. In other words, the product of 3 times 8. So when we multiply them, what they're equal to is going to be the product of the other two boxes. In other words, when we multiply them, blank times blank, we're going to end up with 24. Okay, so we could start to take a look at different factors of 24 and see if any of those add up to 10. 24 is 2 and 12. 2 and 12 do not add up to 10, however. 24 is also equal to 6 times 4. 6 plus 4 does equal 10. So, sorry, 2 and 12 don't add up to 10. We could also try 6 and 4. 6 and 4, if we multiply them, give us 24. And if we add them, we end up with 10. So 6 and 4 are the two missing numbers that we're looking for in our area model. 6 and 4. And again, it doesn't matter where we put which one. Okay, now what we're going to do is look at either the columns or the rows. Let's go ahead and look at the columns. And then we're going to find the greatest common factors and write those at the top. To start off, for 3x squared and 6x, these both share an x. They also both share a factor of 3. 3 can go into both of them. Looking at our right column, here we have 4x and 8. Here, the only shared factor is 4. So 3x plus 4 is one of our sides. Finally, we're going to take a look at the left side and figure out what do we need to multiply in order to end up with the left side. Let's use the right column in this case. Here we have 4 on the top, and we're trying to find the other side where if we multiply by 4, 4 times what? Gives us 4x. In this case, that's just going to be x. Looking at our bottom right corner, 4 times what? 4 times what gives us 8. In this case, that's going to be 2. 4 times 2 gives us 8. Okay, so we filled out our area model. We found the other two sides. That tells us our factored form, or the factors for 3x squared plus 10x plus 8. That's going to be equal to 2x plus 4. Sorry, not 2x plus 4, 3x plus 4. And x plus 2. And that's it. We're finished. So for all of these, we're setting up our area model. It's similar to if we had a coefficient of 1, except when we look at the product, we need to make sure that we multiply that first coefficient by the last number or constant. In this case, 3 times 8, 24. And that's what we're trying to multiply to.